Hi, my name is Peter Law, and I'm going to present my data science practicum. This data science practicum is a computer vision project to detect characters in input images, emphasizing image processing analysis and modeling deep learning techniques. Here is the table of contents for the presentation. I am going to skip number 5, data preprocessing, and 7, image processing, because I did not have enough bandwidth to complete this for the presentation. For me, ordering food in a restaurant without English menus can be a struggle, especially if you're not familiar with the local language. A study reviewed specific accuracy rates for Google Translate across languages, including 94% for Spanish, 90% for Tagalog, but only 77.5 for Vietnamese, which is also the lowest accuracy rate. This project aimed to create an accurate and efficient model for character recognition in menus at Vietnamese restaurant. And to do so, I need to tap into pre-trained models with my datasets of Vietnamese menu images. And by training the model, I hope to automate the task of menu translations. More facts about Google Translate. Google Translate uses computer visions to provide real-time translation services. The app uses a key system called Neural Machine Translations to translate text and objects in real time. Google Translate also uses other techniques to improve translation quality, including subword segmentation, vector mapping, and recurrent neural networks. This is the project outline. The first step is data collection and data preprocessing. To build my dataset, I scrape images of written typed documents in Vietnamese from Google Images using a Google Images scraper. Next step is to convert the raw data, including techniques like data augmentation, normalization, and resizing images. Next is to build the model. I researched similar projects and construct a model architecture using OCR engines. Before doing that, I would begin with a pre-trained model to create a working OCR. Model training is essential. As I built my menu translation model, I must train it with my own data set. First, I would label the names of the top transacted food items, create a dictionaries, so the model could analyze and understand different dish names, ingredients, and descriptions, which would lead to more accurate translation. Here's the project timeline. I recently had a family emergency, so the weeks you saw in red were impacted due to that. As I mentioned earlier, I scrape images from my datasets from Google Images using a Google Images scraper. Um, Although there are some data quality challenges, some images have low resolutions. In addition, menus are cluttered with designs and food photos. Um, and also, there are missing characters, making the OCR think that the language is not Vietnamese. Taking advantage of a pre-trained model, I was able to create a working OCR. This function processes an image, extract text, and display both the images and the recognized text side by side for comparison. Um, in the future, I can expand this code to train new dataset by incorporating test-rack training or train a deep learning model using TensorFlow, PyTorch, or OpenCV. Here are some test results and findings. This is a clean document. So as you can see, data quality matters. This OCR output achieved 100% accuracy. On the other hand, this handwritten note um, poses a challenge to the model. The model recognized that the handwritten note is probably Vietnamese, but its output is unreadable. uh, proving the accuracy limitations of a retrained model. There are definitely challenges and setbacks um, with the test menu that I use for the pre-trained models. As you can see, the output. Vietnamese character pose difficulties due to unique marks and varied font style in menus, complicating image recognition and translation. We want to continue with this project, so there are future steps. Uh, First step is to continue to gather a diverse and extensive data set of Vietnamese menu images to improve model training, um, experiment with advanced image recognition technique, and refine the existing model to improve character recognition accuracy. Um, and if I were to succeed, I would develop a user interface to display translated menu items, making it user-friendly for restaurant patrons. Um, and if I get there, I can test the system in real world scenario to validate performance and user satisfaction, testing the model and interface based on feedback. And that concludes my presentation.